recording. It says it's recording. I see the numbers running. I think we're good. Okay. So what we've now got hold on. Is our top surface, our top profile. And then what we decided that we were going to do was that our next step was to build in and fill in the transition using this side surface as part of the boundary. Now, what we also determined was, hey, we decided that, you know what, we're going to actually use this and add some contour to it to utilize this as the sidewall as well. So what that means is I've trimmed it, but what I'm going to do is I'm going to go back. In order to add the contour, I've got the one curve going all the way along, but I want to make this have some curvature, so I am going to delete this. I'm going to use my center plane, create a sketch, and then we're going to build the surface. Keeping in mind that I still have to remember that this is going to be my part of draft. So I've got to make sure that it starts there. Come on, let go. And again, this is where it gets hard because I don't necessarily like that curve, that shape, but I'm going to have to live with it to a point. So again, let me just check my curvature. I don't have to live with that, but you can see where it gets flat. Now, I showed you how to dimension the other splines. We can dimension this too. This is for, you know, again, when you hand something off to the engineers, if they're going to have to work with it, try to put as much dimensioning in it as you can so that they don't simply come in and have it blown up on them. I believe, yep, I can also dimension the degrees. So we're going to make that 92. The reason I'm making it 92 is because, again, like we talked about, the deeper the draw on something, the more draft you need. So if I have a part that is only 2 inches tall, then my tool only has that amount of space that it has to pull out in that direction. What that means is there's less likelihood of it getting hung up or that the product is too tight on there. So maybe there you only need half a degree of draft. If I have a product that is that much bigger, I don't know what the math is, we'll say 10, you may need to have more draft, which then, so half a degree, let me just see here. So half a degree looks like that on the outside of the wall. All of a sudden having to go to 2 degrees looks like that. So you can see that it's going to change the outside look and shape of it. That's where you want to try to take that in consideration when you're designing it and see what you can do to cheat it. You know, does it need to be this wide? Can I pull this in a little bit to get that and adjust up in here? I don't know. I don't know. Those are things that you want to play with. But again, it starts with my spline to make sure that's on there versus going back in where solid modeling, you do it to the part or the feature. So we've got that. Now what we're going to do is we will do a swept surface. I am going to do this and do this. What? Oh, whoops. I need to get out of... Okay, swept surface. Nope, no. Oh, I want to switch these around. So something there, you don't always have to have the curves for swept surfaces don't always have to be touching. You can have one that controls the direction or the location. So here you can see that I picked the bottom sketch as my profile, and then I picked the side sketch as my path. The profile is the one that it always stays true to. Now, if I switch this around, which is actually what I want to do because I have this cutting in, this is the one that I want to control. If I switch this and I select this first, whoops, you can see that it then has it on the outside. Now, again, direction 1, direction 2, or in both directions. That's because my profile curve is not defined at the end of the curve or end of the path curve. So it doesn't know what to do. So it's basically saying, hey, do you want to only go in one direction or both? In the past, it would just automatically do that. So there we've got our side surface now. And let's go to the side view. We got this sketch. We're going to edit it. And for this, I am going to drag it all the way back. I stopped it here, but the reality is why would I do that? I'm not sure what I was thinking, because I want this surface that I'm going to build right in here to go all the way back so that when I trim this out, it's a smooth transition versus trying to stop there. So let's see. Nope. So I am just going to come in. We're in edit the sketch now. Are we editing the sketch? We're editing the sketch. So I don't want it to be tangent. I want it to be curvature because I want it to follow along that. Kind of like what we talked about last class. I want to make sure that this continues to go in this natural progression. I could simply extend the curve, but I'm not a big fan of that because basically you're hoping that it does what you want it to do. It's kind of the same as extending surfaces. So let's go with curvature. And we're going to say that looks pretty good. So again, build, evaluate, refine. I've got a little bit of a kink there, but I don't think that's going to be noticeable at all. But just in case. And you can kind of see, so here's the weird thing. So here, I can pull it out and drag it, but it's hard for me to see what's going on. Oh, it's not going to let me do that. Never mind. So we're just going to visually try to smooth it out there. And that looks better. I believe you can change these from yellow, but I don't remember what it is. So we've got that. Let's just turn off the curvature cones. Now, I'm not necessarily going to get this right 100% of the time. I may not get it right, period. What I'm going to do now is, and when I say not get it right, I mean this surface may not be the right shape. I might have to go back and tweak it and adjust it and go back and forth. For the sake of today's class, I'm not going to be doing a whole lot of tweaking. So let us come in. We're going to split that face. You know what? We're going to trim that surface. Because I think in order to trim the surface, I need to have this come all the way past. So let me just go in and edit this. So I already know that this is going to be below any of the concept sketch. So I'm not necessarily worried about making that tangent or curvature. Although, with that said, if I don't worry about this being tangent or curvature or anything, what's going to happen is if I need to adjust this up or down, then eventually that surface is going to have a kink in it. So for the 30 seconds it's going to take, let's adjust it, get it right. That's one thing that you should always try to do, and it gets better as you go, but is how much can you think ahead about what I'm doing now, how could it screw me later, so that you're not having to go all the way back to fix something that you might have been a little bit lazy to do. That, what you saw there, was me being lazy for some reason. Okay, we're going to go trim surface, standard. The trim tool is going to be this. We're going to take this, we're going to remove this. And we're going to look at it, and we're going to say, okay, it's looking good. What I do want to do is, since I'm going to be using this edge or this surface and this surface to build along this rail from here and here, I want to make sure that they start. I know that in the past I have seen some of you guys take the approach of drawing a 3D spline from here to here. And I know that, you know, when I see that, I mention to you guys that that's not the best thing to do. The surface doesn't like it. It has a hard time figuring it out. It's not as clean. So what I'm going to simply do is come back. We'll do a side sketch. Actually, so I can do a sketch and trim that surface using that tool. or I've already got the plane built there, I can also trim a surface and use the plane as a trim tool and remove that. So it saves you one step, which if you're saving yourself one step every 15 steps and you have literally 200 steps in here, that's not bad. Okay, so questions to how I've gotten here so far, or the logic? Okay, so if I come back and I look at my car, let's see if I've got, did I draw on that car? So if I look at this, you can see how up here, it's at a flatter angle. It becomes a little bit more drastic down here. It actually starts to get a little bit of a radius here and a twist, and then it kind of twists down as it goes. So when I look at that, and I say, oh, okay, we're getting all these different twists and that in there, and the surface is doing different things along the way. Every time I see it transition at a certain point, and I say, okay, look, I see one thing here, I see it transition to here, I see it transition to here, then I see it transition back down to here. What that means is I want to have control in those areas. And I want to, have control means I have to have a line there. Because if I don't have this line here, what that means is, as we've talked about before, that we're going to rely on the software to figure out what it's going to do in this area. Now, I could right off the bat say, you know what, let me just try it with this profile and this profile, and I won't worry about that, and we'll see what we get. My experience tells me I'm pretty sure I'm not going to get what I want, because I'm going to want to do some fine tuning of what that transition looks like, or whoever the senior designer is or whoever's approving your model may want you to make some adjustments. For example, you know what? I don't like how it starts curving here. Have that be a little bit flatter. Well, the only way to make that flatter and have that different transition is by having that small bridge. So in my mind, it's like, okay, I'm going to do this. I'm going to need at least 1, 2, 3, 4. I may need a 5, I don't know. But I'm going to start with 4. I don't know why I want to color it all of a sudden. I just want to color it. Okay. And then you can also see we have to be prepared, because what we're going to do next is it's going to cut under there. So let's come in. We've got, let me go to my side profile, because I think, okay, so again, I'm going to have multiple planes. So I think what I want to do is, I think I want to just do a sketch, and I'm going to use those sketches as extruded surfaces to get what I want versus constantly coming back. Oh, whoops, I did that wrong. Versus having to try to get the right angle of the plane in that. Because again, if I'm going to do a profile, I want to have it as much of a 90 degrees as I can at that point on the curve. Is that right? So we'll do that one. And this one, so I always like to have a control point before it starts wrapping around on a radius. And you know what? Oh no. So that would have been awesome if I had done that perfectly, where this spline point ended at the same point as this. But that's okay. So that's just really being anal and really trying to make sure I have a clean surface. If I was doing production modeling, then I would make sure that this was in the same spot as this. And the reason for that is, again, those little details helps the geometry to be that much more precise because it has a natural endpoint versus I'm going to loft it to this point here, and then it's going to have to loft there and then loft there. So the more I can clean it up and have a natural transition, the better. I could come back and say, well, let me do that. But then you can see where it doesn't have a natural end to the radius of the curve. So, but this is not production modeling. So we can live with being cheap. So then what we can do is extrude. We're going to extrude in both directions. Okay, we're going to hide our sketches. I can hide those quickly because I can see them because they're named. I don't think I had that line long enough. So let's come back. Because I need it to pierce the other surface. And the reason I need it to pierce the other surface is because I'm going to put that intersection on the surface so I can grab it from there. Okay, now so here is where I have to decide what kind of approach do I want to take. This is a good opportunity where you could use splines, or sorry, 3D splines. Because what's going to happen is I am going to come in and let us, wait, where's my surface? Insert. Where am I going here, people? I want to do a split surface. No. Why am I drawing a blank here? I'm staring right at it, aren't I? That's not what I want.
I usually just type it in up in the little search bar.
Well, that's not giving me what I want. Anyways, okay, I'm not going to worry about it too much. What we're going to do is we will just come in. I'm not going to cut with surface. You know what? We're going to go insert. Oh, come on, Chevy. There we go. We're just going to go split. So we're going to use that trim tool, that, and we'll use that and that. Oh, come on. I don't think I got what I got. Okay, good enough. So here's a couple different things I can do to see what I want. Now, you know what? I'm just going to go back here. So I could take this and I could do a lofted surface. And we're going to come in and go selection manager. We'll grab that. I can just click on here and it'll grab all the tangent lines. We'll come in, we'll grab the next one. Oops. Now what I can do, you can kind of see the surface there ghosted. I could come back and say, okay, we're going to use these control points. Curvature to face, curvature to face, and it doesn't like it. So obviously we're not going to do that then. So the next option is, do you want to do 3D splines? So we could come in, do a 3D sketch, do a spline, drag it there and drag it there. Now, the problem with this approach is, let me come down here because I've got these going on an angle. And that didn't actually split down there, nor did that split there. Oh, come on, Chevy. Oh, that's why. Hold on. forgot if I want to split a surface, I literally have to have it go all the way through the surface. Oh, that's what I wanted. Split line. Whatever. You know what? I'm going to use the split line. So here, what happened is it actually created a separate surface. You know, it broke it out and gave us all those individual surfaces. Versus split line, what it will do is just project that curve onto that surface. It doesn't break it out. Now the nice thing about that as well, and this is why I was confused, is if I'm correct, which I'm not, never mind. But it still stays one surface. So if I want to do a 3D spline on there, the problem is when I go to adjust the one on the angle, if I adjust it from a straight on view, that's not the actual orientation on it. But for intents and purposes for today, we are going to just do 3D splines. Now the nice thing too about this is I can do multiple 3D splines. Okay, Chevy, you're killing me here. This is going to take me the entire class just to get to a stupid spot. There. And you can see by doing that, I grabbed the wrong one. So let's just go back here. 3D sketch, spline, there to there. Now what's nice is, even though I'm doing a 3D sketch, I can still select this and do the dots like I like to. But the trick is, then when I do that, even if I come in and we try to adjust it, when I go to the other side view, it's all over the place. So if you do want to use this method in a 3D sketch, the best way to do it is to have a straight line, and what you can do is use reference geometry. So I'm going to come in here, I can draw this in there, and then what I could do is I could come in and go 1, 2, 3. Remember, the first dot is for tangent, the second dot is for curvature. The third dot, if you want it, is for minor adjustments. 1, 2, 3. And then what I can do is come to the side view. And I can adjust it. What I'm going to do is adjust it now in this view. Now the nice thing is, if I had used the sketch planes versus doing the 3D geometry, I would have easier time trying to figure this out and control it. So you can play with it like that. Now for all intents and purposes, what I'm doing is I'm just going to use the regular spline. Okay, so now what we're going to do, I can already see here, this isn't cutting back far enough. If you look at it, oops, that surface sticks out farther than this. I actually need it to be tucked back further, so I'm not sure what I did there, but I will fix that after I get some of this flushed in. So again, we're going to come back in, we're going to do surfaces. We could do a boundary surface. I view boundary surfaces as something that I use when I feel the surface is going to be a little bit more complex. The boundary surface has it's a little more math heavy, but that's because it can handle more difficult surfaces. So I'm going to be having a variety of points that I'm going to adjust and control. So I think that's going to help me. So we are going to go and loft it. Now here's the thing. I don't know how to apply this to another situation, but what I have always been taught is when I choose my rails versus my contours or guide rails in that, is that my guide rails are the longer lines. You know, the guide rails are the direction that I want the surface to go in. So in this, the surface is going in this direction, not wrapping around this. So it's the length of it. So that's what you choose as your rails. So we're going to come in, we're going to go Selection Manager. And again, Selection Manager because we're selecting multiple edges. And you can see here where I'm getting that little fidget thing. Now, again, if you, what? No, you weren't supposed to do that. If, when you're doing this, all of a sudden says, you know, your guide curve doesn't match with your contour curve, blah, 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 always go in and zoom in to see, do you have one of those little pieces that you're not clicking on? That happens a lot when your curves are a little sloppy or you're just going fast. And then you just got to dive in there deep and pick that piece. So now we're going to pick our contour curves. And right now you can see that by picking our contour curves, whoops, let's pick that. By picking our contour curves, it's actually not changing our surface. And the reason for that is because they're flat and that's a perfectly flat surface and you could just loft it. Let's take a quick look at what everything looks like here. So it looks pretty decent. You can see now as I add, I get these weird lines, and that's probably because I've got these extra breaks in there. Because up here you can see how everything's nice and clean. So at this point, because you saw I had to pick more curves along this bottom edge than I did on this top one. Does that make sense? So we're go ahead.
Can you say that again?
So if we look at, I used this edge and this edge as to create it. But now if you look at it, there is, along this edge that I grouped, there's 1, 2, 3 that I used. But then if I come back here, 1, no, that's not right. Let me redo it here. Okay, so we were talking about lining up curves and getting all these points to be nice on here. If I come in and I go Selection Manager, and I'm going to use this top one, I've got 1 curve, 2 curves, 3 curves, 4 curves. That wasn't the problem area that I used. If I come to the next one, I've got 1, 2, 3, 4, 5. So what that is the surface at a certain point, it doesn't necessarily, it's trying to line it up as best as it can, but it's not, you know, it's just connecting the dots as it can. Again, not going to cause us any harm. If I was doing Class A modeling and someone inspected my model, they would look at that and say, what the hell? So it all depends. But now if you're doing Class A modeling, if someone says do this car and you're just doing it for what we're doing it, and you've got 3 days to do it in, awesome. If someone says you're doing this car and you're doing it in Class A modeling, well, you got 9 days to do it in. It's just that much more precise. So let's come in, we'll grab these again. Oh, wank off. I'm nervous because we have a new person in the class. My anxiety's coming out. There we go. So we've got our surface in there. We just want to make sure that it's nice, it's in there. Before we start adjusting, let's just make sure it's going to knit. Okay, it knit. We're happy with it. Now let's undo the knit. And this is where we're going to go back and start adding in the shape and the contour. So back here is where it started to flatten out. And then up here is where it started to get rounder. So what we'll do is we'll just come in. Looks good. Normally, each time I build one, I would put on my curvature combs, check it, adjust it. You can see there what I did is I caused more problems than good. I went in the wrong direction. Now, a lot of times when you're working with companies, a lot of people argue that you're not even going to see this problem. You're not even going to see curvature. For me, it's the psychological aspect. If something's sitting on a shelf, a person doesn't know why they always like it. When they look at it, they say, oh, I like that. But they're not sure why they like it. They just know that they do. Or in reverse, someone says, oh, I don't like that. I don't know why, but just something about it. I just don't like it. A lot of that can come down to the highlight and how it looks and what you're thinking about it. And that's where it's hard because it's so subjective. At times, I love being an engineer because, you know what? You can't argue with math. Hey, if you apply 200 pounds to this, it's going to break. Therefore, I need a rib. Watch. Stand on it. It broke. Here's a rib. It doesn't break. There's not a lot of subjectivity in that. But in design, there is so much subjectivity. I can argue the psychological aspects of putting a highlight here is going to draw a person's attention to this, and a person can say, well, no, it doesn't. Doesn't do it for me. How am I going to argue that? That's where as designers, we've got to build up. You've got to explain what you're doing, why you're doing it, how it's going to affect things, and then, try to articulate it, explain it, and educate it. So I can already tell that I'm not going to necessarily like these curves because that one is just doing something weird. I don't know why that one blew up because I was doing this. So sometimes, even though it's a transition surface, how is that over defined? Even though it's a transition surface, those transition surfaces can be the most important on your model. And I'll pull up the sketch there in a second and explain why. So we've got that. We've got that. Yes. That's fine. We got that. We got that. I don't understand why it did that. So let's exit out of this and figure out why it just blew up on me. For some reason, it didn't like that one anymore. So we'll just clear that. We'll clear the whole thing. You can see somehow I got that kink back in there, but we won't worry about that for now. Now, I don't know if anybody at this viewpoint can see that kink. It may be partly just because I'm so used to looking for it. But I'll show you in a second. If your eyes aren't good like that yet, oh, I grabbed the wrong thing there. There we go. So I can look at that and say, okay, we're looking good. You know, actually, I'm going to go back and I'm going to say, I don't like this rounded part here. That doesn't hold true to what the vision was. Although this part seems to be doing it. So it's now a matter of going back and refining it. I'm not going to bother to do that just for the sake of speed. But I would probably, you know what, it just bothers me. So one thing that would be useful while we're doing this, or while I'm doing it, is if I had a cross section all the way along, I could be using that to tell me what these surface radiuses should be. So I sketched a cross section here, one here, one here. There are two people who understand building cross sections very, very well. And that is going to be Emma. No, not Emma. Who's doing the mouse hand? Yeah, Emma. Right? Can you guys hear me? Have I been talking to no one?
I think Emma is in the breakout room with, forget what her name was.
Okay, got it.
Hard cat.
Yeah, so Emma's doing a whole lot of cross sections, but it helps to guarantee you know what's going on all the way. And a cross section here that I sketched out and placed on here would help be a lot quicker than me trying to fudge this stuff in. So that is just really bothering me. Okay, so for all intents and purposes, you know what I'm talking about. I'm just going to make that flat. So the trick would be then to go back and edit this how you like it using these profiles. So this should have been a flat one and then slowly curving. But basically now you can kind of start seeing that we're getting what we want. Now for this, we're going to wrap it around. But again, like I said, this didn't pull back right. So we need to go back. Take a look. It's not the split line that we want. There we go. So we want to go with the surface trim. And I just simply didn't pay attention that my side profile sketch didn't match up with the front one. So let's, Oh no, that's not. That's not what I used to trim this, is it? Oh yeah, it is.
Well, if this is just me, but your mic is something really weird.
I can hear you just fine. It must be Cat's internet or something.
Okay. Yeah, because when Kat, you just said that, you crackled like 3 times. Okay, so I'm just going to come back in and just quickly fix this. I'm not going to worry too much about being beautiful. There we go. So we're going to say that's good. Then it's a matter of coming back and building in this surface here. See, and you can see just simply if I had taken the time to get these lines right and nice and lined up, it would have saved me, or it would save me time every time I come in and I have to pick on stuff, because I'm having to pick on multiple lines. So, but now you can start seeing that we're getting that form to the car. What I like to do then is, again, mirror it over so I can take a full look at it. Let's just stitch these. Now this isn't going to look pretty, but again, if I'm doing a surface where I want to pay really close attention to smoothness and all that, then I'm going to come in and toss on a really highly reflective material, which usually I do paint, metallic, and then I toss on like a candy apple red. Let's get a different environment. There, good enough. And I'm going to take a look at that and see how things go. You can see, you know, like along here, you don't see a hard highlight break, which means I've got some nice curvature in there versus tangency. I don't see any weird wobbles or gaps. Although, as we noticed before, there's nothing going on that I can see. I'm using my naked eye to take a look at it. Well, let's go in and do our analysis. And you can see that in this area, it's a little wonky all over the place. And if you look at this green, that matches how those isoparms were transitioning. So it's this, you're never going to notice it for what we're doing. You probably might not even notice it in tooling, but it's just something to be aware of. Because there may be times where it does affect something, or you're asked, you know, whoever's reviewing your models doesn't want to see that, or they don't know that that's okay. And in their mind, well, why is this there? Because this should look just like this. I'm not worried about you guys getting that fixed perfectly. And you can kind of see there, that's, for whatever reason, it's curving in. And that's probably because I didn't use construction lines. Questions so far? Okay, let us take a 10-minute break and then we'll come back. So 7:53, 7:55. Okay?
Because of COVID, like all the shipping containers are like docked in the US and there's nothing going back to China. So shipping containers are really, really, really expensive right now. And so
What's that?
Have you been talking?
Since when?
I've just been listening. I haven't heard anything. I didn't know if my internet went out or something.
Oh, no, I just stopped talking about like 3 minutes ago.